Good morning, everybody, or afternoon, whatever it is in your little time slot of the world. We're going to go ahead today and talk about geometric mean. I can do a video today, a little bit different. I can do a live lesson. It gives you a little bit of a video lesson today. So we're going to talk about geometric means. And it's about similar triangles like we talked about on Tuesday or the last couple of days, whatever. Where we're going to kind of look at different ways to set up these triangles. So we're going to talk about geometric mean today. So our objectives today, find the geometric mean between two numbers and solve problems involving relationships between the parts of right triangles and the altitudes to its hypotenuse. So just kind of some back things to remember when we're talking about different things. A ratio is a quotient of two numbers. In simplest form, it should be reduced in unitless, so fractions. So a ratio is essentially a fraction. So we could have something like the ratio, 3 to 6. That's not in reduced form. Okay, so in reduced form, that's going to be equivalent to 1/2. And that's what that's equivalent to. The ratio of A to B, if A and B are two quantities that are measured at the same units, then the ratio of A to B can be written in any of those four ways. Most notably, we generally see it written in fraction form. And then up top, we have 3/6 equals 1/2. That's called a proportion. We've talked about this before. A proportion is an equation that equates two ratios. It's the means times the extremes. Kind of that cross product butterfly thing. Which ones are the means and which ones are the extremes? Don't really worry about which ones are the means and which ones are the extremes too much. Just know that if we want to test to see if two proportions are equal to each other, we can multiply the means, which is the second and third term, by the extreme and see what they get. So 6 times 1 is 6. That's the means. The extremes is 2 times 3, which is equal to 6. Since those two things equal each other, then they are proportional to each other. And we're going to need that when we're talking about geometric mean. So for example, we could have something like, let's go ahead and solve a over x equals x over b. If we do the means and the extremes, that's taking and multiplying this. So that's x times x is x squared is equal to a times b. And that's really the means times the extremes. Okay, the extremes, they did the extremes first. It doesn't matter. If a and b are positive numbers, then a is a positive number such that, and so on and so forth. Now, you could simplify it, which we didn't do. Another way to write this is to simplify this. You could say that x is equal to plus or minus the square root of ab. Okay. And that's what this would have said in here. It just, for some reason, kind of left out this. This is actually what's called the geometric mean. So we say that x is the geometric mean of a and b if we can solve that piece right there. So x is going to equal positive or negative square root of a times b. X is the geometric mean then of a and b. And that's what we kind of mean by geometric mean. Geometric mean is essentially positive or negative square root of two numbers multiplied together. So if we're going to find the geometric mean of 8 and 18, we're going to say x is equal to plus or minus the square root of 8 times 18. If we take 8 times 18, that gives us 144. So x is equal to plus or minus the square root of 144. So x is equal to plus or minus square root of 144 is 12 and minus 12. So that's the geometric mean of 8 and 18. So x is equal to plus or minus 12, just like we had. So essentially you're taking the two numbers, multiplying them together, finding the square root when you're finding the geometric mean. So by definition then, the geometric mean of two numbers, when multiplied by itself equal the product of the two numbers. Okay, so x squared is equal to a times b. That's what that says. That's how we find the geometric mean. Then we can simplify that into x is equal to positive or negative the square root of ab. And that's just solving for x. That's all that is solving for x. And that's how we are going to go about finding the geometric mean. So if we want to find the geometric mean of 36 and 9, the geometric mean x is going to equal the positive or negative square root of 36 times 9. Grab the handy dandy calculator. 36 times 9 is 324. So plus or minus the square root of 324. We see if 324 is a nice little one, and it is. So our solution here is positive or negative 18. And you're done. Okay. What happens if it's not pretty for you guys today? Let's say that there's a geometric mean. So say we've got 35 and 175. And so if we're going to find the geometric mean of 35 and 175, x is then going to equal the positive or negative square root of 35 times 175. Break the calculator out. 35 times 175, sorry. So that's the positive or negative square root of 6125. We're going to take the square root of that number. And it's not perfect this time. We're just going to write that as a decimal. All I'm worried about today is your ability to find the geometric mean. And the geometric mean of that is 78.3. You don't need to worry about using the factor tree and all of those different types of things. I believe if I hit the button here, you don't have to worry about finding the factor tree. All I want for you to do is find that hypotenuse. Okay, so that's how we go about finding the geometric mean. Now, when do we use that geometric mean? Well, geometric mean is really used if we have a right triangle and we draw in there what's called an altitude. So an altitude is that line right there. So this line CD is called the altitude. An altitude is drawn to the hypotenuse of a right triangle. So if we have any right triangle, we can draw this altitude in there. Okay, and that altitude is always going to go from the hypotenuse, from the right angle to the hypotenuse of that triangle. And now if you'll notice, we really have three triangles that are now created within this little thing. And the way we're going to kind of use geometric mean is we're going to kind of talk about the triangles that are created. And these triangles, or these 2 or 3 triangles, these are actually going to be similar triangles, given that we've got, kind of these right triangles sitting in here. Advance on slide. Okay. So essentially we've got 3 triangles now that are in here. We've got triangle ADC, which is that triangle right there. We've got triangle CDB, which is that triangle right there. And we've got triangle ACB, which is kind of that whole thing. And now you'll notice that these are going to be similar to each other. Okay, now they're going to be similar to each other because of side angle side proportionality, which we talked about on the last lesson. And the reason that kind of happens, and the way we could kind of look at all the problems that we have today, is we could kind of look at these different triangles that are kind of created and kind of rotate these different triangles around and put corresponding parts to them and write out these different proportions to find different lengths. Because when we're looking at the problems today, what we're really going to be doing is we're really going to be looking at not only finding the geometric mean, which was the first part of it, but we're also going to be looking at finding missing parts of right triangles when that altitude is drawn in there. And we could certainly do that by creating similar triangles like we did on the last lesson, and then write the proportions. But instead, we're going to kind of do this using what we call the geometric mean. So there's really 3 types that you could have. Okay, so we've got this altitude drawn in here. Okay, and really then this becomes all about finding different parts to doing this. And again, we could write these as proportions using similar triangles, or we could use kind of the geometric mean kind of shortcut way to do this. So if we've got this right triangle, we've got a leg 1, we've got leg 2, we've got the hypotenuse down there. That hypotenuse is the whole thing. But you'll also notice that really leg 1 is the hypotenuse of ACD, and leg 2 is the hypotenuse of CDB. You know, though it's a hypotenuse for there, and then we've got that altitude that's sitting in there as well. So we've got all of these different parts that we want to be able to always identify when we're doing the problems today. The 2 legs are going to be the outside, the biggest legs that create that right triangle. That altitude is going to drop down, and then we've got this huge, long hypotenuse. And then you'll also notice that it drops it into 2 segments, that hypotenuse. We'll call them segment 1 and segment 2. So at this point, pause the video for a couple seconds. Make sure you get this drawing down there. Okay, now I'm just going to keep going. Okay, so if an altitude is drawn in the hypotenuse of the right triangle, the altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse. So for example, let's say that we're given the altitude, segment 1 and segment 2 from your last drawing. And we want to be able to find these different things. Setting up proportions, and we could take these and draw all of these different triangles and set up proportions to help us find the value of h, or the value of y, or the value of x. We could certainly do that. But it really becomes about the parts. And this is what I want you to get down here. And this specifically is what I want you to write down. If you're given the altitude and you're given the 2 segments, or you're asked to find one of the segments, we can use the formula, the altitude squared is equal to segment 1 times segment 2. Okay, so the altitude squared is equal to segment 1 times segment 2. And you'll notice that that's really just the geometric mean. So the geometric mean of h is equal to plus or minus the square root of segment 1 times segment 2. Okay, so we could then say that h is equal to plus or minus the square root of xy. Okay. And we're going to use this anytime we're given that altitude and trying to find those 2 segments. So we're given 2 of the 3. As long as we're given 2 of the 3 of those, we can do this using this formula. Okay, so that's the first one that you need to get written down. If you don't have it written down, again, press pause. The second type we could have is, let's say, okay, all of that, but let's say that we're given that leg over here, and we're given this little segment along with the hypotenuse. So we're given a leg, the segment that's associated with that leg, and the hypotenuse. The next formula then says that in this case, the leg squared is going to equal the segment times the hypotenuse. So the leg is equal to the segment times the hypotenuse, the leg squared. So then we could say the leg is equal to positive or negative the square root of the segment times the hypotenuse, or A is equal to the positive or negative square root of x times c. And a couple things with this. When you're doing these, one of your givens is going to be the leg. And the segment that has to be associated, it has to be that segment that's right beside it. The leg connects to it. Because we're going to do another formula here in just a second. But it's the leg squared is equal to this part that's here times the whole here. Leg squared, part times whole. Leg squared, part times whole. When we're doing this one. Okay. If we have and say, okay, now instead of A, now we've got this BY on here. So we've got this part and this leg. Okay, it's going to my part's going to roll over. But what we're going to see here is that now b squared, which is this other leg, b squared is going to be y times c. So the other leg squared is equal to this part times the whole. And it's always about the part that associates with that leg. Leg squared is equal to part times whole. Leg squared is equal to part times whole. I might be doing it backwards. I don't know what it's going to look like when I reverse this thing because I'm backwards. But I hope you understand it, that leg squared is equal to part times whole. Leg squared is equal to part times whole. And again, we could re-put this as b is equal to plus or minus the square root of yc. So all this is going to do, these three formulas, are going to allow us to find different pieces of these triangles instead of making and drawing these triangles, which can get confusing. Okay, so let's look at some examples. Okay, so pause for a second, draw the triangle. I'm just going to go. So we're given that this part is 3, AD is 3, DB is 9. They want us to find CD. We'll just call it X for now. They want us to find AC. That's Y for now. And they want to find BC, which is Z for now. So we've got our three formulas. So we've got our altitude now is CD. And we said our altitude squared was equal to part times the part, segment times the segment. Our segment is 3, our segment is 9. So x squared is going to be 3 times 9. So 3 times 9 is 27. So that's 27. So we'll say x is equal to plus or minus the square root of 27. That's going to be the altitude. And we can just, again, just put this in your calculator. I'm not going to worry about you breaking it down. It's 5.2. So the length of this x is 5.2. The next one we're going to find is y. Okay, y is one of the legs. Y is the leg AC. CD is the altitude. So when we talked about the leg, we say that leg squared, so leg squared, y squared, is equal to the hypotenuse segment that's connected to it. So that's 3. So 3 is the hypotenuse segment that's connected to it. It's part times whole. So the part is 3, the whole is 3 plus 9, which is 12. So y squared is going to equal 36. So y is equal to plus or minus the square root of 36, which is just 6. And why am I putting 6 and not plus and minus 6? Because we're talking about sides of triangles. They can't be negative. Okay. So next one we have to find is z. Z is the other leg of our big right triangle. So leg is equal to part, leg squared is equal to part times whole. So z squared, the part that's connected to it, is 9. The whole thing is 12. So that's z squared is equal to 108. Z is going to equal the square root of 108. Square root of 108 is 10.4. And that's your solution. So we said y was 6. This is 10.4. And this is always the formulas that we are going to use to do this. Okay. Again, they're going to rotate it. I am not going to do those. They put little u's after them. They put 3 times the square root of 3. That's 5.2. Okay. We're just putting the decimals. We're not breaking them down. There it goes. Okay, we're going to cross all of this out right here. Okay, so go ahead and draw this. I'm going to tell you that this here is 60. This is 36. And this whole thing is x. And we want to find the value of x. Okay, so I look what I have. I've got a leg, and I've got a segment and a hypotenuse. So remember, the leg squared is equal to the part, which is 36, times the whole, which is x. And these are more of the types of problems you're going to get today. Okay. 60 squared is 3,600. That equals 36x. Divide that by 3,600 by 36, and you get x is equal to 100. And there's your solution to this. Next one. Let's get the pen going. We're going to go, this is 14, this is 6, and this is x. Here's my right angle. So first think about what you're given. You're given a leg. So the leg squared is equal to part, which is 6. Now what's the whole thing? 6 plus x is the whole thing. Now we solve this. There's not going to be x squared in this one. So 14 squared is 196. Distribute. 196 minus 36 is 160. 160 divided by 6 is 26.7. So there's your value of x. Okay. Let's look at another one. So there's my right triangle. There's my altitude. This time I'm going to tell you that that is x. This is 18, and the whole thing is 25. So now we have to think about what we're given. We're given the altitude, and our rule is the altitude squared is equal to segment times segment. Not segment times whole, it's segment times segment. So my first segment is 18. How am I going to get my second segment? Well, I know the whole thing is 25, so 18 plus 7 is 25, so that's going to be a 7. 18 times 7 is 126. Square root of 126 is 11.2. There's your value of x. Let's look at another one. There's my nice right angle. There's my altitude. There's my leg. I'm going to give you that this is 60 and this whole thing is 100. We want to find the value of x. So we're given a leg. So leg squared equals part times whole. Well, remember when we're talking about part times whole, this is the part that I have to use. What's that part? Well, the whole thing is 100. This part is 60. So our part is 40. The whole is 100. Leg is equal to part times whole. So x squared equals 40 times 100 is 4,000. The square root of 4,000 is 63.2. So there's your value of x. Let's look at one more. So here's our right triangle. I'm going to drop that altitude down. This time I'm going to tell you that the altitude is 40. This is 30. We want to find the value of x. Leg squared is part times part. So my altitude squared, my bad. Leg squared, sorry. Altitude squared is equal to segment times segment. So altitude squared is equal to segment times segment. So 40 squared equals 30x. 40 squared is 1600. That equals 30x. Divide both sides by 30. X is equal to 53.3. Okay. So there's what we have today. Again, kind of keep in mind when we're doing this, the geometric mean. X is equal to the positive or negative square root of AB. That's your geometric mean. When we're talking about our right triangles, we've got this altitude down here. We'll call this X, Y, Z, A, B, and this whole thing is C. Remember that your altitude squared is equal to segment times segment. Your leg squared, in this case Y, is equal to part that's connected to it times the whole. And Z squared is going to equal the part that's it's connected to times the whole. And this will allow you to find the different pieces of right triangles that are drawn by an altitude. I've got your assignment today. It's a geometric mean assignment. The first 6 questions, you just have to find the geometric mean. So questions 1 through 6 are going to use this. Questions 7 through 18 are going to use one of those. And each part is only one. You don't have to find multiple pieces on them. You just have to find one at a time. Go ahead, get to work on your assignment, and we will see you next time.